This video is a review of factoring techniques. We'll cover greatest common factor, trinomials, a equal to 1 and a not equal to 1, and difference of squares and sum and difference of cubes. The first thing that we need to know about factoring polynomials is to find out what a factor means. To factor something means to write it as a product. So we want to write these as a multiplication instead of the way they look right now. Now, always we want to look for a greatest common factor first, the largest thing that each of these terms have in common. So in this case, 2, 4, and 6 are all divisible by 2, and each one of these terms also has an x. So I'm going to factor that out. Now, when I say I'm factoring it out, I'm dividing it out. And so when I take out a 2 and an x, I'm left with an x squared here. Here I'm left with a minus 2x and then a plus 3. You can check yourself by distributing back through and making sure you got what you started with. On this next example, the GCF is 11x, which is this entire thing. But remember, that's really 11x times 1, if that helps you. And we're going to take out an 11x. So dividing by 11 gives me 3. And dividing by an x gives me x squared. And if I'm actually dividing by 11x, I get 1 left over. If you don't write that 1, when you try to distribute back through, you'll notice you're missing that last term completely. So what students mostly have to do, obviously finding a greatest common factor is a very good skill, but you need to be able to factor a trinomial. So a trinomial is a polynomial with 3 terms, and we're first going to look at those where the coefficient of the squared term is 1. And as always, we're going to look for a greatest common factor first. So we're going to start up here. X squared minus 7x plus 12. 7 is a prime number, so there's nothing going to be common there. First 2 terms have an x, the second one doesn't, or the third one doesn't, so there's no GCF here. What we're going to do is our list factors of our constant, in this case 12. So we're going to get 1 times 12, 2 times 6, and 3 times 4. And I need to find 2 numbers, they're going to call them here P and Q, that will add to this middle term, -7. So because this is a plus sign, we're multiplying. They either have to be both positive or both negative. And because this second is a negative, we know we're going to have both negative. So we're going to use -3 and -4. And then we're going to write down our double bubble, and then we're just going to plop in our -3 and our -4. And if you FOIL this out, you're going to see that you get what you started with. So we're going to do that a couple more times. Let's take a look here at x squared plus 6x plus 8. Again, we notice that this second is a plus, so I'm going to either have 2 positives or 2 negatives. And they need to multiply to 8, 1 times 8 or 2 times 4. And I think you can see that if we use +2 and +4, they will add to 6 and multiply to 8. So we write down our double bubble, x plus 2, x plus 4. All right, let's do a couple more. Factors of 14, 1 and 14, 2 and 7. Now this one's different. This has a minus sign here, which means one of our numbers is going to have to be positive and one of them is going to have to be negative. Can't even get a 5 out of 1 and 14. But I could if I had -2 and +7. X plus 7, x x minus 2. And it does not matter which order these factors are in. So take a moment. I am going to write down the answers to these next ones. Don't forget to look for a greatest common factor first, and then pause your video and then turn it back on, and I will have the answers there for you. So hopefully you got the right answers here. We've got x plus 7, x minus 9. This one was prime. We cannot get a 2 out of the factors of 3. And this one here, we had to factor out a 2 first, and then we factored the remaining polynomial, x plus 2, x plus 6. The next thing that we want to do is look at trinomials in the form ax squared plus bx plus c, where a in this case is not equal to 1. As always, we want to make sure that we're looking for the GCF first, greatest common factor. So we're going to look at this first example. We'll follow these steps here. So when I look at 10, 2 times 5, and 17, which is prime, and 3, which is prime, there is no GCF. So in this particular case, we don't have to worry about that. What we're going to do is multiply the first times the last. So 10 times 3 is going to give me 30. And just like before, we're going to list factors of 30. 2 times 15, 3 times 10, and 5 times 6. And I'm looking for two numbers in that list that I can get a 17 out of. So in this case, I can get a 17 out of 2 and 15. So I am going to rewrite this 10x squared plus 2x plus 15x plus 3. So all I've done there is taken this middle term and broken it up into two terms. Because once I have 4 terms, I can factor by grouping. So we're going to look at just these first two and take out the GCF of those two. I'm going to say that that is 2x, leaving 5x. Now remember, if we take out the whole thing, we have to leave a 1 in its place. And then over here, I'm going to take out a positive 3, also leaving 5x plus 1. And you should notice that 5x plus 1 and 5x plus 1 are the same. So we're going to factor out that binomial, 5x plus 1, and it's going to leave us with 2x plus 3. So here we have our factored form, and of course, as always, we can multiply it out to check. So let's do that a couple more times. Let's take a look here at 3, 11, and 20. Any common factors there? I don't think so. 3 and 11 are prime. So we're going to multiply 3 times negative 20 and get negative 60. And I'm not going to worry about my signs here. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, 6 times 10, and then we're back to 10 times 6. And we want to be able to get an 11x out of those. Can I get an 11? Well, I think I can get 11 with minus 4 and positive 15. So unlike before, I can't just go straight to my double bubble because I have this coefficient here, but I can rewrite this. I'm going to rewrite the 11x as minus 4x plus 15x minus 20. And then I'm going to take out of the set of two terms, I'm going to take out the greatest common factor. So in this case, an x, leaving 3x minus 4. And here we can take out a 5, leaving 3x minus 4. And then these match. So we'll take that out as a binomial, 3x minus 4, and it will leave us with x plus 5. Let's do one more that way, and then I'm going to show you another way with the same 3 examples. So let's take a look at 12x squared minus 8x. 12 times negative 15 is negative 180. So if we list our factors, we know one of them has to be negative, but we'll just leave those off for now. 2 times 90, 3 times 60, 4 times 45, 5 times 36, 6 times 30, no 7. How about 9 times 20, 10 times 18, and 12 and 15, and then the next one is 15 and 12. And by the way, making this list is the hardest part, but in your calculator, you can do y equals negative 180 divided by x, so like you're going to graph it, and then hit the table. You might want to set up your table to start at 1 with a change in x of 1. So it'll divide by 1, divide by 2, divide by 3, and so on. And you will get this list. You'll also get some decimal answers in between, but we know that those aren't perfect factors. So looking carefully at our list here, we want to have two numbers that differ by 8. Differ by 8. I think that's going to be 10 and 18, and that's going to have to be positive 10 and negative 18. 12x squared plus 10x minus 18x minus 15. So again, all we're doing here is stretching that out. And then we will factor what we can out of the first two. Looks like a 2x, leaving 6x plus 5. And you'll notice now I have this negative. Let's definitely take out a negative. And I believe we can take out a negative 3 is the common factor. So we'll get 6x plus 5. Change the sign because we took that negative out. And then we will factor out that 6x plus 5. And we'll be left with 2x minus 3. And again, this is in factored form. If you want to check and make sure you did it correctly, then you can multiply it out. So I would like to show you something on the next page that a lot of students have not seen before. I'm going to use the same 3 examples, and we're going to do this a different way. So I've written the same 3 polynomials, the same 3 trinomials down, and we're going to start exactly the same way as we did before, and we're going to multiply the first times the last. 10 times 3, we'll get 30, and we'll list our factors of 30, which if you recall, we used 2 and 15 because that gave us 17. So 2, positive 2, positive 15 gave us positive 30 and added to 17. So what I'm going to do with those two numbers is I am going to rewrite them here with their signs, and I'm going to divide by the lead coefficient. Then what we need to do is reduce. If we don't do this reducing step, it won't work. We'll get 1 over 5. This one reduces by a factor of 5, 3 over 2. The last step is to bring these bottom denominators up and get 5x plus 1 and 2x plus 3. And you can check it's the same as we got before. Let's take a look at this next example. If you recall, we multiplied 3 times negative 20 and got negative 60. We made that same list, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. We used positive 15 and negative 4. Those will multiply to negative 20 and add to 11. We're going to divide by our lead coefficient, which is 3, and then we're going to reduce. Now, make sure you leave your signs there because that's important. We're going to get positive 5 over 1, and this one doesn't reduce, minus 4 over 3. And then again, the last step is to bring this up and write your double bubble. And you're going to get 1x plus 5 and 3x minus 4, which is the same thing that we got last time. We don't have to write the 1 in front of the x. Okay, one more. Go ahead and try this one. We know that 12 times negative 15 gave us negative 180. I'm going to use my knowledge from before. We actually used negative 18 and positive 10. So that step, finding those numbers, is exactly the same. This time, we're going to divide by 12. And we're going to reduce. And we're going to get, dividing by 3 for this first one, negative, I think I can divide by 6. Negative 3 over 2. And this one I'll divide by 2. Positive 5 over 6. Then we will bring these up and get 2x minus 3 and 6x plus 5. So that's just kind of a different way to do that. I find a lot of students like it, so I just like to show it to people. Okay, we have a couple more things. I know this video is getting kind of long, but I didn't want to make two. We want to do the difference of two squares. So a difference of two squares is exactly what it says. It's a perfect square minus a perfect square. And what we know is that that will multiply, or that will factor as a plus b, a minus b. And I want to show you why. If we FOIL this, we get a squared minus ab plus ab and then minus b squared. And what you should notice is these two add to 0. So we actually just get a squared minus b squared. These are fairly easy to factor if you recognize your perfect squares. Always, always look for your greatest common factor first. So this one is x squared minus 2 squared, right? So this is going to be x minus 2, x plus 2. I'm going to rewrite this one. 9x. Oh, excuse me, it's not a 9, is it? What's squared there is the 3. So we're going to write 3x, quantity squared, minus 4 squared. And then we'll get 3x minus 4 and 3x plus 4. Okay, no GCF on this next one. It's 10 squared minus x squared. So 10 minus x and 10 plus x. So make sure that you do this in order. Very often people are used to seeing the x first, but if the 100 is first, then the 10 has to be first in your factors. X would be second. Last example here for difference of two squares is 3x squared minus 12. Well, 3 is not a perfect square, but maybe it's a greatest common factor, which in this case it is. So we'll factor that 3 out. That will leave us an x squared minus 4, and then an x minus 2, x plus 2. All right. The last thing in this factoring review is the sum and difference of cubes. And my recommendation here is to build it, not to memorize A's and B's. So the first thing you're going to do is you're going to write down a small factor, 2 terms, and a large factor. So I'm going to do that down here. Small factor, large factor. The next thing is an acronym, SOAP. And SOAP means same, opposite, always positive. So we're going to look at this sign, which is a plus, and we're going to put our signs in here. It's going to be the same as the original, opposite of the original, and always positive. Then I'm going to ask myself, what's cubed first? In this particular case, the thing that's cubed is a. So I'm going to put that a here, and then I'm going to square it here. And then I'm going to do the same thing with the second term. What's cubed second? And that happens to be b. So I'm going to do a b here and a b squared here. And then I'm going to multiply the a and the b. And I've already got my sign, so I don't have to worry about it. And I get the minus ab. So let's take a look at this example. What's cubed here? This is a 3x cubed plus 1 cubed. So we're going to build it. We're going to build our sum of two cubes. Small factor, large factor. The sign is plus, so it's going to be the same, opposite, and always positive. Then we ask ourselves, what's cubed? Well, 3x is cubed. And then we're going to square the 3x and get 9x squared. Then we ask ourselves, what's cubed second? And that's a 1. So we'll put a 1 here, and we'll square it and put it at the end. And then we'll multiply the 3x and the 1, and we'll get 3x. So that's exactly the same for a difference of cubes. We're going to have a small factor and a large factor. The sign, since this is a minus, is the same, opposite, and always positive. We're going to get a and a squared, b and b squared, and then we'll multiply these two together and get ab. So let's look at this example. I'm going to think of this as 2y cubed and 5x cubed. So you don't have to do that step, but sometimes it's helpful. We're going to have a small factor and a large factor, and we're going to put our signs in there. So this is a minus sign here. We're going to do minus, the same, opposite, and always positive. We're going to say 2y is what's cubed here, and then we'll square it and get 4y squared. 5x is the second thing that's cubed, and we'll get 25x squared. And then we'll multiply those two together, regardless of the sign, 10xy. So as long as you build it, it's not too terrible. I am going to skip factoring expressions using fractional or negative exponents, and that will conclude this video. Thank you.